ได้มีชื่อเสียงที่มากขึ้นเพราะสิ่งที่เขาได้คือได้แค่ความรู้สึกได้เห็นความสุขได้เข้าใจได้ความรักได้ในสิ่งที่เงินซื้อไม่ได้ได้โลกที่สวยงามกว่าเดิมในชีวิตคุณอะไรคือสิ่งที่คุณต้องการมากที่สุด
All right, guys. So I just found this video, and it doesn't really have anything to do with the lesson, but it does kind of do with life. And just, sometimes when you're going through life, you do nice things, and you feel like you're not rewarded for them. Don't ever stop doing nice things. It's a good way just to kind of could be in general. So today, what we got planned for you is we're going to be taking a look at the Pythagorean Theorem. And I just, again, want to get you guys kind of kickstart here, maybe motivate you a little bit. But this is something that you guys have been using for quite some time. You've probably seen this since Algebra 1, and it's a really important lesson, one of the most important lessons I think you will learn in geometry personally. So let's kind of take a look at this and see where we go with it. But here we go, Theorem 9.4, Pythagorean Theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. All right, so we're going to start off by drawing ourselves a right triangle. Okay? And there are three sides. There's two legs, leg, leg, and there's your hypotenuse. All right? So the legs are your A and your B. I'm sure you guys have seen this equation once or twice. Your A and your B, and your hypotenuse is your C. The A and B are almost interchangeable. If this is A, that's okay. If that's A, that's fine. But the C must be your hypotenuse, which is always your longest side of your right triangle. Or the other way to think about it is the side across from or opposite of your right angle. And our Pythagorean theorem is a squared plus b squared equals c squared. Okay? There's our great formula of them all, so we can use that a good bit, right? Now, to kind of go with this, we have a very important idea called a Pythagorean triple. It's a set of three positive integers, a, b, and c, that satisfy the equation c squared equals a squared plus b squared. So here's a quick example, 3, 4, 5. Your c is always your largest number. So if I were to plug this in, 3 squared plus 4 squared equals 5 squared, the reason Pythagorean triples are so nice is that they work out perfectly. 3 squared gives us 9, 4 squared is 16, and 5 squared is 25. And 9 and 16 add together to give us 25. 25 equals 25. There we go. Okay, but they're all three of these are positive integers. Okay, normally when we're doing Pythagorean theorem, you're going to run into a few square roots. Okay, which we're going to see in just a moment. We would simplify them down, but they are not positive. They're not integers, rather. Okay, they're just positive rational numbers. So, all right, let's take this and apply it a little bit here. We got a few questions to take a look at. Number 1, find the unknown side length using the Pythagorean theorem. Simplify answers that are radicals. Tell whether the side lengths form a Pythagorean triple, right, yes or no. So we have a few things going on here. Our first goal is to solve for a missing side. So you want to identify the x in this problem. Is that a leg or is that a hypotenuse? Well, since it is across from your right angle, this is going to be your hypotenuse. Due to that fact, we now know that this x is going to be the c in our Pythagorean theorem. Okay, so I'm going to call this A, I'm going to call this B, and now we're going to go ahead and see what we can do with it. So we got 15 squared plus 8 squared We're going to set that equal to 8 squared, or x squared. So 15 squared gives me 225, plus 8 squared gives me 64, equals x squared, right? I can add those two numbers together, just to show you guys via calculator as well, which you're always feel free to use here. 225 plus 64 gives me 289, equals x squared. Now, a nice thing to do to check yourself, make sure you're okay, is we're going to hit square root of 289, and we're just going to check to see if it's a perfect square, okay? In this case, it is. We get 17 because we got square root both sides, equals x equals 17. So, due to that fact, look at our sides now. We have sides 8, 15, and 17. Are they all positive integers? Yes. Okay, there's no radicals in there, there's no decimals, so this would be, yes, Pythagorean triple. Alrighty, there we go. We've answered everything we need to do. We just double check ourselves. Simplify answers that are radicals. Okay, we didn't have that. We're good. They form a Pythagorean triple. Yes. We're good. Okay. Okay, let's take a look at a few more here. Number 2, again, identify first. What's the x? Is it a leg? Is it a hypotenuse? In this case, it's a hypotenuse. So again, the x is going to represent the c in our Pythagorean theorem. Here's our a, here's our b. You don't have to label them every time, but just if it helps, go for it. So 8 squared plus 12 squared equals x squared, right? We're squaring things out. 64 plus 144 equals x squared. If I were to add this together, again, we can go ahead and take a look here. Light on here. Hopefully that helps me. That makes me a little bit better. 64 plus 144 gives us 208. All right, so 208 equals x squared. All right, now just to check myself, square root 208. All right, 14.42. Now, this is telling me that this is not a perfect square, which is all right, but now we have to break it down. So I'm thinking about perfect squares that can go into 208. Just to start out here with, let's take a look. How about like 16? Does that work? Okay. Now I just randomly picked one there. And you can try out all your perfect squares there. You can figure out which one works. So here we've got root, when we take square root of both sides, we have square root of 16, which is right here, times the square root of 13 equals x. And then we can break this down one more time. Square root of 16 is 4. Square root of 13 is still square root of 13x. Okay. Now, before we circle answer and say we're good, just check root 13. Can any perfect square go into this? No. Okay, it's prime number, so it's not going to be anything besides 1 itself. Box it off. We're good. Now, to ask ourselves, this is a Pythagorean triple. All right, here's our slide links. We have 8, we have 12, we have 4 root 13. Okay. Do I have any radicals in there? Why, yes, I do. So this would not be, no, not Pythagorean triple. Okay, there we go, all good. So those are 2 examples of one where you have a Pythagorean triple and one where you don't, all right? Both of these examples had your x being your hypotenuse, okay? So there are going to be times when the x is not the hypotenuse, which we're going to take a look at down here, but we're going to get back to this in just a few minutes, all right? Hopefully this lesson helped so far, and as always, good luck to everyone. We're all counting on you.